Let's practice some solutions chemistry here. These are covering dilution, and there is an equation that students use for dilution all the time. Most of us call it M1V1, some call it C1V1. It is a ratio equation that works well for dilution. I'm intentionally not teaching it because students use it inappropriately in other systems. So if you use it correctly, that's great. But if you don't use it correctly, you won't get points. So we are trying to not teach it to you guys actively so that you don't mess it up down the road in an improper situation. Okay. So you can do it without it though, just as easily. What is the final concentration if 12 milliliters of a 12 molar HCl solution is diluted to a volume of 250 mils? If I want concentration, concentration is the same as number of moles of what you're looking for, which is HCl, per liters of that solution. So here it's telling me I took 12 and a half mils of a 12 molar solution and diluted to 250 mils. My 12 molar solution means I have 12 moles of HCl for every 1 liter of HCl. And my 12 and a half liters means I have 0.0125 liters of that HCl solution. This step right here gives me my moles. So I have my numerator. Now what I need is that denominator. So I'm going to divide this system by my total volume in liters. 0.250 liters of my HCl solution because that's what it's been diluted to. Now I've got liters of my solution, which is what I was trying to find. So now I've got the right denominator and the right units to match the molarity. And I see that the solution here is 0.60, let's see, sig figs, 3 sig figs, 0.600 molar HCl. And I had 3 sig figs here, 3 sig figs here, 3 sig figs here. So my final answer needs 3 sig figs as well. Next example, what is the concentration of a solution of hydrochloric acid that was prepared by diluting 5 mils of a 12 molar HCl solution to 150 mils? Same setup we just did. I want the number of moles of HCl per liters of my HCl solution. I've got a 12 molar solution, so 12.0 moles of HCl over 1 liter of HCl. And I'm diluting 5 milliliters of it, which is 0.00500 liters of HCl. Don't want to drop those sig figs. Again, just cancels out my liters. And I've got my moles, which is my numerator. I've got to get that denominator in place. So I'm going to divide this by the volume. It is diluted to 150 mils, but I need that in liters, 0.1500 liters of solution. So now I look at it and I've got my liters of solution. I've got my conversion or my ratio I want, and I get a total solution here. Let's see, 3 sig figs, 0.400 molar of HCl. Again, 3 sig figs, 3 sig figs, 4 sig figs. My final answer can have 3 sig figs. That's why I'm carrying those zeros along to make sure that I have the right number of sig figs. And this one, what is the concentration of the solution described below? Okay, I don't know, let's see what's happening. I have 10 grams of a cobalt 2 chloride dihydrate that's weighed out on an analytical balance. I then add that to, let's see, it looks like I add a portion of the solvent is added to the volumetric flask. So I add the solid. You can see the solid in the volumetric flask. I add your cobalt. Cobalt's a blue color. I can see the cobalt in there, and then I add some water to it, and I mix it up really well. And then I add additional solvent up to the mark on the volumetric flask. And this isn't really actually dilution, it's a solution preparation question, but we'll go ahead and do it here because this is where it's saved. What I want is number of moles of cobalt 2 chloride over liters of my solution. Notice I'm not writing the dihydrate here because water's going to just make more of it in the solution, but I do have to factor that water into the mass of the compound, okay? So what I want is the number of moles per liter of solution. I've got 10.0 grams of COCl2 to H2O. I'm putting this into a volumetric flask that's 500 milliliters. 500 milliliters is the same as 0.500 liters, but volumetric flasks have a very precise measurement to them, and 500 mil ones are actually precise to 500.0 mils. Depending on the calibration, it could be 2 decimal places. We're going to assume that it has 4 sig figs overall. So we're going to say 0.5000 liters. Okay. Now, I wouldn't expect you to know that. I would expect you to use at least 500, like 500, so at least 3 sig figs. So 0.5000 liters of solution. Now I should get in the right units. Well, I want moles in the numerator, so 1 mole of cobalt 2 chloride, hexahydrate. Do not forget the hexahydrate in the mass. It will not give you the right answer. You have to factor them into the mass. Is 165.3 grams of COCl2 to H2O. Again, if you don't know the mass, go online. ptable.com is a great website to help you find the periodic table. It's got a lot of information on it as well, but you should always have a periodic table with you when you're studying as well. Let's see, I wanted my liters in the denominator. I've got my liters in the denominator. I wanted my moles in my numerator. I got my moles in my numerator. My grams have canceled out. I got the right units. Calculate this out and I get 0.121 molar COCl2. So again, I'm factoring that water into the mass of the solution because it is part of the salt. The water is actually trapped in the crystal structure there. We've talked about that when we talked about naming. But when it's dissolved, the water just adds to the water in the system. So my overall solution is 0.121 molar.